In this video, I will be going over reference angles. So reference angles are useful when we are trying to evaluate sine, cosine, tangent values using the unit circle. In this image, the blue angle is always the reference angle. So the reference angle is here, 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 and here. And the red angle is the original angle. So, for example, let's look at this one over here. The red angle, theta, is something in the third quadrant. Let's say it's 225 degrees. The reference angle, this image is calling it theta prime, is the angle between that 225 and the x-axis. So we know the x-axis, that angle is 180 degrees. So 225 minus 180, we're left with 45 degrees. Okay, so the reference angle is always the angle formed with the given angle and the x-axis. Okay, so that's an informal definition. More formal definition would be this. For this definition, we have the acute angle, so an angle between 0 and 90 degrees, formed by the terminal side of an angle and the horizontal axis. A reference angle is always between 0 degrees and 90 degrees, or 0 and 2 pi radians. So let's look at this second image here. So we have our original angle theta. The initial side of that angle is here. The terminal side is wherever that angle ends. So when we say terminal side of an angle, that's what we're talking about. And then the horizontal axis. So that's why we want this angle right in here. That is the reference angle. And so, that angle, the reference angle that it just drew, is between either 0 and 90 degrees or this made a mistake over here, not 2 pi. We want pi over 2. So again, the reference angle over here is between 0 and 90 degrees or 0 and pi over 2 radians. So let's do some examples of finding reference angles. So the first one is find the reference angle for 240 degrees. Now let's just get a visualization of what this is. 240 degrees. Well, we start on the positive x-axis, 90 degrees, 180. So 240 is about 60 degrees more. So that right there is going to be that angle, 240 degrees. So the reference angle is the angle that gets us back to the x-axis as quickly as possible. So this angle right here is going to be the reference angle. So we know that 240, we pass beyond 180, and then there's 60 degrees left. So that reference angle is going to be 60 degrees right there, because halfway around is 180. The second one, we have 2 pi over 3. So 2 pi over 3. From the unit circle, we know that 2 pi over 3 is in the second quadrant. That's going to be something like this. So there's that initial angle, 2 pi over 3. So what we want is what's remaining down here. And that will be the reference angle. Now, halfway around the circle is 180 degrees, or in radians, it's pi. So how we can think about this is all the way around, or I should say halfway around, is pi, and then we want to subtract that 2 pi over 3. So we're going to say pi minus 2 pi over 3, and that will be the reference angle. So this is 3 pi over 3, so we're left with pi over 3 as the reference angle here. The next one, we have 330 degrees. That is almost one full rotation around the circle, we're going to end up, start here, 330 degrees. It's going to get us down here. The reference angle is this angle that's remaining to get us back to the x-axis, and that is 360 degrees minus 330. So what's remaining is 30 degrees. All right, and then the last one, let's go to the next slide. The next one we have negative 13 pi over 6. Okay, so we need to first figure out which quadrant negative 13 pi over 6 is. Let's do a little bit of calculation here. So negative 13 pi over 6, that is equal to negative 12 pi over 6 minus pi over 6. And the reason I broke it down into 12 pi over 6 is because that is equal to 2 pi, which is one rotation around the circle. So negative 2 pi is going to, because the angle is negative, we're going in the clockwise direction. So we're going to end up there, and then we have pi over 6 further. So that angle is going to be in that position. Okay, so all we need to do is what's left over to get us back to the x-axis, and it's this angle right here. Now, because initially we went negative pi over 6 in the green portion, well, that distance, that angle is just positive pi over 6. So the reference angle here is going to be pi over 6. And it's not negative pi over 6 because if we go back to our definition, the reference angle is always between 0 and pi over 2. In other words, it's always positive. Okay, so that's why this reference angle is going to be positive pi over 6. All right, and then let's wrap this up with a couple examples. So our first angle here is 135 degrees, and what we want to do is find the reference angle, the quadrant of the terminal side, and then the sine and cosine values for the angle. So my suggestion would be to draw where this angle is. So 135, it's above 90, greater than 90 degrees, less than 180. So it's somewhere over here. So that angle is 135 degrees. So the reference angle is the angle that gets us as close to the x-axis, or the quickest angle, shortest angle to the x-axis. So 180 is halfway around. 180 minus 35, we're left with 45 degrees. So the reference angle is 45 degrees here. The terminal side of this angle is this part, right? The initial side is where we start. The terminal side is where we end. So that's quadrant 2. And then we want sine and cosine of 135. So sine of 135 degrees. Sine is positive in the second quadrant, and 135 is going to be square root 2 over 2. All right, and then cosine of 135 degrees. Cosine is negative. Cosine corresponds to the x-coordinate, so the x-coordinate is negative in quadrant 2, and that's going to be negative root 2 over 2. These are just unit circle questions. All right, and then let's look at a second example here. We have 5 pi over 3. We want to find the same information. So 5 pi over 3, that is in quadrant number 5. So we're going to go around to here. If for some reason you don't recognize that 5 pi over 3 is in quadrant 4, I know that because I have the unit circle memorized. Another way you can figure this out is, well, 5 pi over 3 is less than 2 pi because 2 pi is the same thing as 6 pi over 3. 5 pi over 3 is less than 2 pi, so it must be less than one entire rotation around the circle. You could also convert this into degrees. 5 pi over 3 is the same thing as 300 degrees. And we have 270 down here, 360 here. So a couple different ways you could identify that this angle in radians is in quadrant 4. So we want to find the reference angle. The reference angle is going to be this angle right here. So we would do 2 pi minus 5 pi over 3. So 6 pi over 3, which is equal to 2 pi, minus 5 pi over 3. So we end up with pi over 3 as the reference angle. One thing you may start to notice when we're talking about reference angles, anytime we have an angle that's in radians, such as this with 5 pi over 3, the reference angle is always just going to be the pi value divided by the given denominator. So that's kind of a shortcut. So if our given angle was 11 pi over 6, the reference angle would just be pi over 6. All right, the terminal angle we already said, or the terminal side of the angle we already said is in quadrant 4. And then we want to find sine of each of these. Sine of 5 pi over 3, cosine of 5 pi over 3. Sine 5 pi over 3, so in quadrant 4, sine is negative. So what we're going to end up with is negative root 3 over 2. Cosine is positive in quadrant 4, and we end up with 1/2. So lastly, let's just talk about why reference angles are useful. So suppose we want to find the value of sine of 300 degrees. Well, if we think about how this is working on the unit circle, 300 degrees is down here, 300 degrees. Okay, so that angle is going to look like this. Okay, so at 300 degrees, we want to find the sine value there. Now, think about what the reference angle is here. The reference angle is 60 degrees. So if we think about what the sine value is for 60 degrees, well, 60 degrees is in quadrant number 1. The coordinates for 60 degrees are, let me write this a little more precisely. So 60 degrees is up here. The quadrants for 60 degrees, the coordinates for 60 degrees, we have 1/2 for the x-coordinate, positive root 3 over 2 for the y-coordinate. So what we said, when we are in quadrant 1, the first coordinate is positive, the second coordinate is also positive. When we're down here in quadrant 4, the first coordinate, which is x, is positive. The second coordinate, which is y, is negative. Okay? So what we see here is, if we wanted to figure out what sine of 60 degrees is, we just take root 3 over 2. Now 60 is the same as the reference angle for that 300 that we were thinking about, or that we were originally being asked about. So the value is going to be the exact same. The only difference is what the sine, plus or minus, is going to be on that value. So in other words, sine of the reference angle is root 3 over 2. 60 is the reference angle for 300 degrees. So the value is the exact same. The only thing we need to consider is this positive, is this negative? It's negative because we're down here in quadrant 4. So negative root 3 over 2. So that's the value. So when we're trying to think about and remember the values on the unit circle, really, if you can just remember what's happening in quadrant 1 and how reference angles work, this is kind of a shortcut to find the certain trig values. Let's do a second one here. So we want cosine of 4 pi over 3. Okay, so 4 pi over 3, that's bigger than pi, so that is going to be down here. Okay, so if we think about this on the unit circle, let me draw a circle. radius 1. All right, so, and that angle that we said is 4 pi over 3. Well, what's the reference angle here? The reference angle, what we said is the reference angle when we are in radians is always just this pi over 3. So this reference angle here is pi over 3. Well, pi over 3 is in quadrant 1, and we already saw what the coordinates are. We did that in the previous one, 1/2 root 3 over 2. So let me rewrite this. So when we think about this, really, let's figure out what cosine of the reference angle is. Cosine of pi over 3. That is 1/2. So the value of cosine of 4 pi over 3 is the exact same, 1/2. We just need to think, is cosine positive or is cosine negative down here in quadrant number 3? Well, in quadrant 3, the x value is negative, the y value is also negative. Cosine is the x value, so it's going to be negative. So negative 1/2 is what we would get here.